Okay, so today we're going to do 3.4, Communicate with Algebra. You are to complete this on your own, this activity. This is just a worksheet. Really, you should be completing it on your own, and I am going to go over it now after you have completed it, but you should be trying to do this independently. Okay, if you've looked at the example on page 131, that should help you, and you can see that Jim earns $7 per hour at his job, and if he works for X hours, his earnings in dollars would be 7 times X. So the expression is 7X in this case. The coefficient is the number in front of the variable, that's 7. The variable is, of course, the letter, that's the X, and you could say, there's not much to say in this one for a comment. Next, the depth in meters of a falling stone in a well after t seconds is minus 4.9 t squared. The expression is the whole thing, minus 4.9 t squared. The coefficient is minus 4.9. The variable is t squared, and the comment you could say is that the negative sign is included with the coefficient. So you could say the negative sign is part of the coefficient. Okay. The area of a triangle with base b and height h is 1/2 base times height. You know that. The whole expression is 1/2 base times height. The coefficient is 1/2. And there are two variables in this case, base and height. So you could say the variables can be more than one letter, or one symbol, if you will. Okay. The area of a square with a side length k is k squared. So the whole expression is k squared. The coefficient is 1, not 0, and the variable is k squared. So if no number and you're multiplying, then you would have a coefficient of 1. Amir walks 6 blocks to school. The expression is just 6. The coefficient is 6, and there is no variable. So you don't always have to have a variable, and this term is called a constant if it has no variable. So in other words, it's just a number. Okay. So now let's see if we can complete this. The coefficient 2, the variable y. Coefficient minus 3, variable x. The coefficient 1, the variable is mn. The coefficient is 1/2, the variable is x squared. The coefficient is negative 1 here, and w squared here, and negative 0.4, and gh squared here. So terminology, so again, just read about monomial, binomial, and trinomial on page 131. Monomial means there is one term, and an example of that would be something like 2x. A binomial means there are two terms, and terms are separated by pluses or minuses, so I might have something like this, 2x plus 3x squared. So there's one term, there's another term. Binomial. Trinomial, 3 terms, so you might have a plus b plus c. 3 different terms being added together. Okay? All right. Keep on going here. So go back and classify each of these by the number of terms it has. So because they're being separated by plus signs, this has number of terms, 2, and so it's a binomial. This one, there is a negative sign there, but that's dealing with the coefficient. So there is only one term here, and that's called a monomial. This one has two signs separating three terms. So this is three terms, and it is a trinomial. And lastly, 1, 2, 3, 4 terms. And we call that a quadrinomial, or four-term polynomial, I guess is what they're referring to. Okay. So classify each of these by the number of terms. So this is monomial. This is trinomial. This is binomial, trinomial, binomial, and four-term polynomial. Okay, now this can get a little bit confusing. So if you're on page 132, it does say, give you the definition of the degree of a term. It's the sum of the exponents on the variables in a term. Okay, in a term. So if we look at our terms, this is one term. The sum of the exponents in this case, there's only one exponent, and it's 2, so the degree is 2. This one, the coefficient doesn't count as an exponent, so this one has the sum of the exponents is 4, and so this is a 4 term. Let's just put degree 4. This one, again, coefficient and only one variable, so the sum of the exponents here is 1, and so this is a degree 1. Here we get a little more complicated because we have two different variables with two different exponents, and we have a coefficient. So we add up the exponents and we get 3. So the sum of the exponents there, 3. This one as well, the sum of the exponents is 2, so this is a degree 2 polynomial, or degree 2 term. And then minus 5 has 0 degrees. Okay, there is no variable here, so it's like saying it has degree 0. Okay, so that's the degree of a term. Okay, now let's practice. So we've got this one, the degree is 2. This one, the degree is 1 because there's that invisible 1 there. The degree is 0 because there is no letter. This one we add up the exponents and we get 6. This one we add up the exponents and we get 5. This one we add up the exponents and we get 3. Now we want to classify polynomials by their degree. So the degree of a term and the degree of a polynomial are two different notions. The degree of a polynomial is the highest degree term. So the degree of a polynomial is the degree of the highest degree term. So if we look at this one, this has a degree of 0, this term. We already decided that numbers by themselves have the degree of 0. This term has a 1, so the term with the highest degree is the x. The degree of the term, this is 1, so the degree of the polynomial must be 1. If we look at this next one, there are two terms. the term with the highest exponent is this one. So the term that has the highest degree is 5x squared. The degree of the term is 2, and so the degree of the polynomial must be 2. You do not add up the exponents like you do on the degree of a term. So this one, we look individually at the 3 terms, and we see the term with the highest exponent is the first one there, 3y cubed. The degree of the term is 3, and therefore the degree of the polynomial is also 3. Okay, this one's tricky. So let's look. We've got a 2 and a 4 here and a coefficient. So 2 plus 4 is 6. So the degree of this term is 6. The degree of this term with the 1 is 7. So x to the 6 times y is the term with the highest degree, and the degree of the term, this term, is 7. So the degree of the polynomial is 7. Okay, I know that's a little bit tricky. So let's try this. State the degree of each polynomial. So the degree of this polynomial is 1. The degree of this polynomial is 2 because that's the highest term. This is the highest term here, so that's 3. Ooh, this one's tricky. Let's see, these add up to 5, but these add up to 7. So the degree of this whole polynomial is 7. And then this is 4, but this is 6. So the degree of the entire polynomial here is 6. Okay. Cheryl works part-time as a ski instructor. She earns $125 for the season plus $20 for each children's lesson and $30 for each adult lesson that she gives. Write an expression that describes Cheryl's total earnings for the season. Identify the variable and the coefficient of each term and explain what they mean. All right, so we usually have let statements here that say let A and represent. So I'm just going to throw that in here. Represent the number of adult lessons and let C represent the number of children's lesson. Okay, so now that I have that, I know that she's going to get $20 for each children's lesson, so 20 times C plus 30 times A plus $125 flat fee as well. So that's an expression for her total earnings. So one of the terms, 20C, the variable is C, and the meaning of the coefficient, really 20 represents the earnings per children's lesson. And 30A, A is the variable, and 30 represents the coefficient, represents the earnings she gets per adult lesson. And the last one is 125. There is no variable and there is no coefficient, but this is a constant term. Constant means she gets a flat fee of $125 per season. Okay. One winter, Cheryl gave 8 children's lessons and 6 adult lessons. What were her total earnings? Well, that's pretty easy. We've got an expression, right? So her earnings are going to equal 20C plus 30A plus 125. So that's going to be 20 times the children's lessons, which is 8, plus 30 times the adult lessons, which are 6 of them, plus 125. So that's 160 plus 180 plus 125. So she earned 340, 465. Therefore, Cheryl earned a total, and make sure you put your units in your therefore statement, so $465. All right, so you can go ahead and work on your homework now, please. Thank you.